Chapter 3. Separation of substances. Subject name is science. Substances. Substances are pure forms of matter that have a definite composition and distinct properties. They cannot be separated into simpler components by physical means. Examples of substances include elements and compounds. An element, such as oxygen or gold, consists of only one type of atom. A compound, such as water, H2O, or table salt, NaCl, consists of two or more different elements chemically combined in fixed ratios. Mixtures. Mixtures are combinations of two or more substances that are physically mixed together but can be separated by physical means. Examples of mixtures include air, which is a combination of various gases like nitrogen, oxygen, and carbon dioxide. Another example is saltwater, which is a mixture of salt, solute, dissolved in water, solvent. Other mixtures can include a mixture of sand and sugar, or a combination of different types of nuts and dried fruits. Why do we separate substances? Separation. Separation is a fundamental process that enables the isolation of different substances or components from a mixture, allowing for their individual handling, analysis, or utilization. It involves the application of specific techniques or methods based on the properties and behavior of the substances involved to achieve effective separation. Separation process. Separate stone from rice. Separating stones from rice is important to prevent damage to cooking utensils, protect teeth from potential harm, and ensure a pleasant eating experience. It also helps maintain the integrity of rice-based products during processing, packaging, and distribution. Churning milk to obtain butter. Churning milk separates the fat globules from the liquid, resulting in the formation of butter and buttermilk. Butter is a versatile ingredient used in cooking, baking, and food preparation, while buttermilk has culinary uses and can be consumed as a beverage. Separate tea leaves. Separating tea leaves from the brewed tea allows for a visually appealing and clear beverage, enhancing the sensory experience. It also prevents the consumption of residual tea leaves, which may have a different texture and taste than the desired liquid. Purpose for separation. To separate two different but useful components, separation enables the extraction of distinct components with specific properties, allowing for their individual utilization in various applications. For example, separating oil from water in an oil-water mixture allows the extraction of oil for use in cooking or as a fuel source. To remove non-useful components, separation is employed to eliminate components that do not contribute to the desired properties or functions of a substance or product. Removing non-useful components improves the efficiency, purity, and overall quality of the final product. To remove impurities or harmful components, separation is crucial for eliminating impurities or harmful substances that may compromise the safety, effectiveness, or compliance of a substance or product. For instance, separating heavy metals from wastewater helps protect the environment and prevent contamination. What do we do with the separated components? We throw away the solid component. In some cases, the solid component separated from a mixture may have no further use or value, and it is discarded as waste or properly disposed of. This ensures the removal of unwanted materials or particles from the desired substance or product. We throw away the impurities. Separated impurities, such as contaminants or unwanted substances, are typically disposed of to maintain the integrity, quality, or safety of the desired components. We use both components. When both separated components have value or utility, they are utilized in different ways based on their properties and intended applications. This may involve further processing, recycling, incorporating into other products, or using them in different industries or sectors. Handpicking. Handpicking is a simple and manual method of separation where the desired substances are physically selected or removed by hand from a mixture. It involves visually identifying and selectively picking out the desired components while leaving behind the unwanted materials. Handpicking is commonly used when the mixture consists of large, visible particles or when the desired substances have distinct characteristics that make them easily recognizable and separable. For example, in agriculture, handpicking is often employed to separate ripe fruits from the plant, where farmers manually select the fully matured fruits and leave behind the unripe ones. Threshing. Threshing is a mechanical method of separation primarily used in agriculture to separate grain crops from their stalks or husks. The process involves beating or striking the harvested crop to dislodge the grains from their surrounding structures. Traditionally, threshing was performed by using tools like flails or beating the crop against a hard surface. Nowadays, it is often carried out using mechanized threshing machines. Threshing enables the separation of the valuable grains, which are the desired components, from the inedible parts of the plant. This method is commonly used for crops like wheat, rice, barley, and oats, where the grains need to be separated for further processing, storage, or consumption. Winnowing. Winnowing is a traditional method of separation used to separate mixtures of solid particles based on their weight in the action of air or wind. The process involves tossing the mixture into the air or subjecting it to a stream of air. The lighter components, such as chaff, dust, or husks, are carried away by the air currents, while the heavier components, such as grains or seeds, fall back down. Winnowing takes advantage of the difference in density between the components of the mixture to achieve separation. This method is commonly used in agriculture to separate grain crops from chaff, straw, or other unwanted particles. It is often performed outdoors, allowing the wind to assist in the separation process. Sieving. Sieving is a mechanical method of separation that involves passing a mixture through a sieve or mesh with uniform-sized holes or openings. The mixture is poured onto the sieve, and the particles smaller than the sieve openings pass through, while the larger particles are retained. Sieving is primarily used to separate solid particles of different sizes, where the desired component is of a specific particle size range. This method is widely applied in various industries, including construction, mining, food processing, and pharmaceuticals, to separate particles of different sizes or remove impurities. For example, in the culinary field, sieves are commonly used to separate flour from lumps or to sift ingredients to achieve a uniform texture in baking. Sedimentation. Sedimentation is a separation method that takes advantage of the differences in density between solid particles and a liquid medium. The process involves allowing a mixture to stand undisturbed, allowing the denser solid particles to settle down due to gravity. Sedimentation occurs because the solid particles are heavier and less buoyant compared to the liquid medium, causing them to sink to the bottom. This method is commonly used to separate a solid-liquid mixture where the solid particles are relatively large and settle over time. For example, sedimentation is observed when muddy water is left undisturbed, resulting in the settlement of mud particles. At the bottom, decantation. Decantation is a separation technique used to separate a mixture of solid particles and a liquid by carefully pouring off the liquid while leaving the settled solids behind. After sedimentation, the liquid portion is slowly and gently poured or decanted from the container, taking care not to disturb the settled solids. Decantation is effective when the solid particles have settled at the bottom, and the liquid is clear enough to be separated without significant contamination. It is commonly employed to separate a mixture where the solid particles have settled after sedimentation, such as decanting clarified liquid from a suspension or separating a precipitate from a supernatant solution. Filtration. Filtration is a separation method that involves passing a mixture through a porous material or filter medium to separate solid particles from a liquid or gas. The mixture is poured or forced through the filter, allowing the liquid or gas to pass through while retaining the solid particles on the filter medium. Filtration relies on the size and nature of the particles being separated and the pore size of the filter medium. This method is widely used in various applications, such as in laboratory settings for separating solids from liquids, in water treatment plants to remove impurities, and in air filtration systems to trap airborne particles. Evaporation. Evaporation is a separation method that involves the conversion of a liquid into its gaseous state by heating or exposing it to suitable conditions. The process takes advantage of the differences in boiling points or vapor pressures of the components in a mixture. By heating the mixture, the component with the lower boiling point or higher vapor pressure evaporates first, leaving behind the other components in a more concentrated form. Evaporation is commonly used to separate a solvent from a solution, where the solvent is selectively evaporated, leaving behind the solute as a residue. This method finds applications in various industries, such as the concentration of fruit juices, the production of salt from seawater, and the recovery of volatile substances. Condensation. Condensation is the reverse process of evaporation and is a separation method that involves the conversion of a vapor or gas into its liquid state. It occurs when a vapor or gas cools down, resulting in the formation of liquid droplets. Condensation is employed to separate volatile substances from a gas mixture by cooling it, causing the target component to condense while the others remain in the gas phase. This method is widely used in distillation processes, where vaporized components are condensed to obtain purified liquids or separate different substances based on their boiling points. Additionally, condensation plays a vital role in various natural phenomena, such as the formation of clouds and the water cycle. Can water dissolve any amount of a substance? Solution. A solution is a homogeneous mixture composed of two or more substances, where one substance, called the solute, is uniformly dispersed in another substance, called the solvent. Solutions are formed when the particles of the solute are evenly distributed and interact with the particles of the solvent at a molecular level. Solutions can be in various states, such as solid, liquid, or gas, depending on the state of the solvent and solute. Solute. The solute is the substance that is dissolved in a solution. It is the component present in a smaller quantity or proportion compared to the solvent. The solute can be a solid, liquid, or gas, and it can vary depending on the specific solution. Solvent. The solvent is the substance that dissolves the solute to form a solution. It is the component present in a larger quantity or proportion compared to the solute. The solvent can be a liquid, but it can also be a gas or a solid, depending on the specific solution. Saturated solution. A saturated solution is a solution in which the solvent has dissolved the maximum amount of solute that it can hold at a given temperature and pressure. In a saturated solution, any additional solute added will not dissolve and will remain as undissolved particles at the bottom of the container. The concentration of the solute in a saturated solution is at its maximum level, and the solution is in a state of equilibrium. Unsaturated solution. An unsaturated solution is a solution in which the solvent has not dissolved the maximum amount of solute it can hold at a given temperature and pressure. In an unsaturated solution, more solute can be added, and it will continue to dissolve until the saturation point is reached. The concentration of the solute in an unsaturated solution is lower than its maximum solubility, and there is still room for more solute to be dissolved. Effect of temperature on saturated and unsaturated solutions. In general, an increase in temperature increases the solubility of most solid solutes in liquid solvents. For saturated solutions, if the temperature is increased, the solubility of the solute usually increases, resulting in the solution becoming unsaturated. Conversely, if the temperature decreases, the solubility decreases, and the solution may become supersaturated. For unsaturated solutions, an increase in temperature can typically dissolve more solute, while a decrease in temperature may cause some dissolved solute to precipitate out of the solution. The effect of temperature on solubility depends on the specific solute-solvent system and is described by solubility curves or tables specific to each system. Exercise. Question 1. Why do we need to separate different components of mixture? Answer. When two or more substances are mixed together, we call it a mixture. Sometimes, different components of the mixture are not useful or may even be harmful. So, we need to separate different components of the mixture. Question 2. What is winnowing? Where is it used? Answer. Winnowing is used to separate heavier and lighter components of mixture by wind or by blowing air. This method is commonly used by farmers to separate lighter husk particles from heavier seeds grain. Question 3. How will you separate husk or dirt particles from a given sample of pulses before cooking? Answer. Husk or dirt particles from pulses are separated by handpicking. The method of handpicking is normally used for separating slightly larger size impurities like pieces of dirt, stone, husk from wheat, rice or pulses. Question 4. What is sieving? Where is it used? Answer. Sieving allows fine particles to pass through the holes of the sieve. In flour mills, impurities like husk and stones are removed from wheat by sieving. Question 5. How will you separate sand and water from their mixture? Answer. Steps of separating sand from water. I. Allow mixture to stand in a glass. E. Sand settles at the bottom. E. Clear water forms at upper layer. IV. Gently pour this water in another glass. Question 6. Is it possible to separate sugar mixed with wheat flour? If yes, how will you do it? Answer. Yes, it is possible to separate sugar with wheat flour. I. Mix sugar in wheat flour in lot of water. E. Filter it. E. On the filter paper is wheat flour. IV. Dry it, get wheat flour. V. Filtrate is a sugar-water mixture. We evaporate this to get sugar. Question 7. How would you obtain clear water from a sample of muddy water? Answer. Method of obtaining clear water from a muddy water. I. Allow muddy water to stand. E. Mud settles at the bottom. E. Upper layer is clear water. IV. Decant it. We then filter this water again to remove traces of mud particles. Question 8. Fill up the blanks. Answer. The method of separating seeds of paddy from its stalks is called threshing. B. When milk, cooled after boiling, is poured onto a piece of cloth, the cream is left behind on it. This process of separating cream from milk is an example of filtration. C. Salt is obtained from seawater by process of evaporation. D. Impurities settled at the bottom when muddy water was kept overnight in a bucket. The clear water was then poured off from the top. The process of separation used in this example is called decantation. Question 9. True, false. Answer. E. A mixture of milk and water can be separated by filtration. False. B. A mixture of powdered salt and sugar can be separated by the process of winnowing. False. C. Separation of sugar from tea can be done with filtration. True. D. Grain and husk can be separated with the process of decantation. False. Question 10. Lemonade is prepared by mixing lemon juice and sugar in water. You wish to add ice to cool it. Should you add ice to the lemonade before or after dissolving sugar? In which case would be possible to dissolve more sugar? Answer. We should add ice to the lemonade after dissolving sugar. It will be possible to add more sugar before adding ice.